Hey everyone, and welcome to The Explainer. Today, we're going to be testing the locks on the internet's front doors, and you might be surprised how easily some of them can be picked. Let's get into it. You know that login page you see every single day for your bank, your email, all your favorite sites? How sure are you that its front door is really locked? I mean, really? What if I told you that sometimes all it takes is a little jiggle to get it right open?
So in this explainer, we are literally opening up an ethical hacker's playbook. These are the good guys, right? The ones who find the cracks in the walls before the bad guys do. And our focus is going to be on one of the most critical areas there is: authentication. It's basically the bouncer at the front door, checking your ID to make sure you are who you say you are.
All right, so we're going to break down 3 common plays from that playbook. Think of these as 3 different ways an ethical hacker tests the strength of that digital front door. Okay, play 1, checking names. This first move is all about reconnaissance. It's kind of like walking up to an apartment building and just checking the names on the mailboxes to see who lives there. Sounds harmless, right? But this simple piece of information can give an attacker a massive head start. The technical term for this is username enumeration. It's a really subtle flaw where a website accidentally gives you a clue. It basically tells you whether a username is real or not. Now, it might not sound like a big deal, but trust me, for an attacker, it's the first thread they can start pulling to unravel the whole thing. So, why should anyone care about this? Well, once an attacker has a list of real, confirmed usernames, they're no longer shooting in the dark. They can start launching very specific attacks. They can try guessing common passwords on real accounts, or they can craft super convincing phishing emails. Basically, this tiny flaw just handed them a hit list on a silver platter. So how do they actually find this clue? It's a pretty simple comparison test. You use a tool, something like Burp Suite, to sit between your browser and the website and just listen. First, you try to log in with a totally fake username, something like non-existent123, and you watch what the server says back. Then you try a real username, but with a bogus password. And here's the key. You compare the 2 responses. If there's any difference at all, bingo, that's the leak. And here is that leak in plain sight. With a fake username, the server says user not found. Makes sense. But for a real username, it says incorrect password. See that? That tiny difference is huge. The website just confirmed that the second username is a valid account. And just like that, the attacker has their foot in the door. Now, the clue isn't always a different error message. It can be way more subtle. Sometimes the server just takes a little bit longer to respond for a real username. We're talking milliseconds, because it's actually doing the work of checking the password. Or maybe you'll see a different HTTP status code, or the length of the response is a few bytes off. An attacker is a detective here, looking for any tiny repeatable difference that gives the game away. All right, let's move on to play number 2, the VIP pass. So forget about picking the lock. What if you could just print your own all-access VIP pass right at the front door? That's exactly what this next test is all about. I know, it sounds kind of crazy, right? Just ask to be an admin? But you would be absolutely shocked how often this can work. See, when you sign up for a new account, your browser sends a bunch of data to the server. And sometimes, hidden in that data is a little tag that says what kind of user you're going to be. So, what if you could just, edit that before you send it? Okay, so here's how it works. When you're on a sign-up page, your browser bundles up all your info and sends it off. An ethical hacker will use a tool to basically step in the middle and catch that data packet before it gets there. This lets them look inside and see exactly what's being sent. And every now and then, they find some very interesting and very editable parameters. And once they've caught that data, it's game on. They can just edit it. They might see a little line in there that says role equals user, and they'll just change it to role equals admin. Or they see verified equals false and flip it to true. Or my personal favorite, premium equals 0 becomes premium equals 1. Now, if the server on the other end is built to just blindly trust what it's being told, poof, they just created an admin account or got a free premium subscription. The fallout from this is, well, it's bad. It's immediate and it's severe. You're not just getting into someone else's account. You are creating a God mode account from thin air. This can lead to a complete takeover of the system, massive data theft, or, Just a whole lot of people giving themselves free stuff, which can really hurt a business's bottom line. Okay, time for our third and final play, the copied key. For this one, we're not focused on getting in, we're focused on what happens after you're already in. Think about it like this. Your login is like a hotel key card. It gets you into your room. But what if that key card still worked even after you checked out?
This particular flaw is called session reuse. You see, when you log in, your browser gets this thing called a session token. That's your digital key card. It's what keeps you logged in as you click around the site. The problem, the huge, massive flaw, is when you click that log out button and the website doesn't actually invalidate your key.
And the test for this is super straightforward. First, you log in like normal and you find and copy that session token, that digital key. Then you click around, maybe check your profile. Then you log out properly. Now, here's the moment of truth. You take that old key you copied, you stick it back into your browser, and you try to go back to your profile page. If it lets you in, Houston, we have a problem. The key still works.
The impact of this is, frankly, terrifying. If an attacker manages to steal one of these session tokens, and it's not that hard to do on, say, a public Wi-Fi network, they can just waltz right into your account, and they can stay there long after you think you've logged out. It gives them this persistent, invisible access, and it might last for hours or even days. So, there you have it. 3 plays, we've checked names on the mailbox, we've printed our own VIP pass, and we've used a key that should have been thrown away. Each one of these isn't just a tech flaw, it's a flaw in the site's business logic, the fundamental rules of how it's supposed to operate.
And this quote right here just nails it. Finding these kinds of problems isn't about finding a typo in the code. It's about understanding what the business wants to happen and then finding where the technology just doesn't follow through. It's about finding those gaps where the real-world rules like only an admin can be an admin get broken.
And look, these are just 3 of the most common plays. What they really show us is that keeping our digital lives safe isn't just about having a super long password. It's about all these little rules, the simple logic that we just assume is working correctly behind the curtain. So now that you know a few of the plays, it kind of makes you wonder, doesn't it? Which of your digital doors aren't nearly as locked as you think they are? Thanks for joining us on The Explainer.